Hi, I am Mr. Peck from Ideas Inc. School, and we are here today to discuss about an application of force known as pressure. What is pressure? Pressure is defined as the force that is acting normally or perpendicularly per unit area of contact. A standard international unit for pressure is either newtons per meter squared or Pascal. As a result, the formula for pressure is P equals F divided by A. However, please note that all units used in physics formulas must be in SI units. And because of that, the force must be measured in newtons and the units for area must be in squared meters. We can convert squared centimeters to squared meters by dividing by 10,000. Next, we will talk about the two ways to increase pressure. We can increase pressure by applying a greater force over the same area. Or we can increase pressure by applying the same amount of force on a smaller area. Hence, we use this concept to improve our quality of life. Let me give some examples. Bags are designed with wider straps for comfort as its weight is spread over a larger area. This helps relieve pressure exerted on the shoulders. Knives have a very sharp edge in order to apply a greater pressure to cut through materials easily. Soccer boots with studs are worn to exert more pressure on the ground. This helps soccer players achieve more grip and they will not slide over easily. Heavy construction cranes and vehicles use wide tires or caterpillar wheels so that they do not sink into the mud. The heavy weight of these vehicles are spread over a larger surface area to reduce pressure exerted on the ground. When walking on snow, we wear snowshoes that have a wide surface area so that we do not sink too deeply into the snow. And this is also the reason why people are not allowed to wear stiletto heels on fragile and brittle flooring. For the next part of the chapter, we will be discussing about how the pressure formula is used. Please pause the audio and refer to the question in the notes. Let's begin. Firstly, we have to convert the mass of 5 kilograms into weight. We do so because all the units in the pressure formula must be substituted in SI units. We obtain the weight by multiplying the mass of 5 kilograms by the gravitational pull of 10 newtons per kilogram. If done right, we will obtain a weight of 50 newtons. Now we need to choose the correct side of the box. In order to achieve the greatest pressure, we will need to select the smallest area. The smallest area can be found by taking 15 centimeters multiplied by 10 centimeters. However, since the area must also be in SI units, we will need to convert 150 squared centimeters to squared meters. And because 1 squared meter is equivalent to 10,000 squared centimeters, we can convert the area of 150 squared centimeters to 0.015 squared meters. Finally, in order to obtain pressure, we take the force of 50 newtons and divide it by the area of 0.015 squared meters to get a pressure of 3,330 pascals. On the other hand, if we wanted to find the least pressure exerted by the same box, we simply need to select the largest area instead. The largest area on the box has a dimension of 30 centimeters by 15 centimeters. Thus, the area will amount to 450 squared centimeters or 0.045 squared meters if converted correctly. The least pressure can then be found by taking the same weight of 50 newtons divided by 0.045 squared meters to obtain 1,110 pascals. We have reached the final section. In this part of the chapter, we will be discussing about atmospheric and water pressure. First off, what is atmospheric pressure? This is the weight derived from the layer of air that is surrounding the Earth. This layer of air exerts a pressure on the Earth's surface, thus giving rise to atmospheric pressure. We experience about 100,000 pascals of atmospheric pressure at sea level. However, this pressure decreases with altitude. Here is an interesting fact. It is actually easier to boil water on Mount Everest than at sea level. At this high altitude, the boiling point of water decreases due to the low atmospheric pressure. This is because it takes less energy for the water molecules to break free from each other and escape the liquid surface into the air as gaseous molecules. Let's take a look at other uses of atmospheric pressure in our daily lives. When using a rubber sucker, the sucker must first be pressed against the smooth surface to force out as much air as possible. This reduces the internal air pressure, and since the external atmospheric pressure is greater, air will exert pressure on the sucker, pushing it against the surface. Next, why are sports cars so low to the ground? This is because the small gap will reduce the volume of air between the car and road, thus reducing the air pressure in this region. And as a result, the higher atmospheric pressure above the car will push the car towards the ground, stabilizing the car when it is traveling at high speeds. Lastly, how does a straw work? When air is sucked out of the straw, the pressure inside will decrease. Due to the difference in air pressure, the greater atmospheric pressure will cause the external air to push liquid into the straw. Finally, we will be studying about water pressure. Water pressure follows Pascal's law, which states that Number 1. Water pressure will increase with depth. And number 2, if there is a pressure change in any point of a confined liquid, there will be an equal change in pressure at every point of the liquid. This is why the opening of a dam must be located far away from the water surface. When that occurs, the pressure of water gushing out will be very high, and thus more kinetic energy from the flowing water can be converted to electrical energy. Haskell's law can also be applied to the hydraulic brakes in cars. By applying a force on a brake pedal with a small area, we can generate a high pressure. And since this change in pressure of a confined liquid is equal everywhere else in the liquid, this will allow a transfer of large force being applied to the brake pads to slow down a moving vehicle. For a clearer understanding on how this works, you can pause the audio and refer to the diagram in the notes. We have come to the end of the chapter. If you have any doubts, please approach Mr. Peck. Thank you for listening and have a nice day.